right, so today I'm going over the 7.3, ooh, now I lost it, 7.3 workbook, I believe it was. Yeah. So I'm going to go over these really quickly. I'm not going to write everything out. I'm just going to kind of walk you through the steps here. So basically, shoot, I shouldn't have closed that. Sorry, give me 1 sec. I'm just going to open up the workbook again so I can actually read the questions. So the first one here was 7.3 2b. And it's basically just saying if you were to solve these using the quadratic formula, what values of a, b, and c would you use in each case? So if you have a formula set up and it's not in the standard form of like something x squared and then something x and then a number, then you need to make it into that. So basically with the way that this was set up, this was your original question. So it was -2 x minus 1 squared minus 1, and it was set equal to 0. So that's good because you don't have to move anything over. So then basically all you needed to do was expand the squared one, and then so I set it into the two separate brackets, and then I multiplied those through using FOIL. So x times x is x squared, x times -1 is -x, -1 times x is -x, and then -1 times -1 is +1. And then we still have the -1 on the outside. And then when you go over here, I would simplify it by combining like terms. So because we had -x minus x, we get -2x. Everything else stays the same. And then we have to multiply this 2 through by everything inside the brackets. So -2x squared, -2 times -2 gives us +4x, and -2 times 1 gives us -2. Now, and then we still had the -1 on the outside of the brackets, so we don't multiply that value through. Okay, and then we can simplify by combining like terms. So there's no other squared terms, so we keep that. Same thing with the x, and then we combine these two. So -2 minus 1 gives us -3, and so the values we would use would be a is -2, b is 4, and c is -3. Okay, the next question was 4b. So with 4b, let me just take a quick look here. It says solve each quadratic equation, identify equations that do not have real roots, otherwise give an exact answer. So just remember with the exact answer, you're not going to solve for like the number value in decimals. You're going to leave it basically in this kind of quadratic form. So for 4b, what we were given was 5x squared equals, oh shoot, and I didn't copy that part down. So what you were given on the piece of paper was, actually I could probably just pull that over. This 5x squared equals 6x plus 2. So it's right there at the bottom. 5x squared equals 6x plus 2. And what we always need to do to use the quadratic formula is that our equation has to be set equal to 0. So because this one here has, it's not set equal to 0, we need to move everything to the same side. So for me, I wanted to keep my a value positive, so I moved 6x over. Because it's positive 6x, I had to subtract it, and same thing with positive 2. So I end up with 5x squared minus 6x minus 2 equals 0. So now my a value is +5, my b value is -6, and my c value is -2. And then I can just start putting in my quadratic formula. So -b, so -6 gives us +6, plus or minus the square root of b squared. So -6 squared is going to give us 36, minus 4ac. So altogether, that is going to give us 76. And then divided all of that by 2a, so 2 times 5 is 10. So we end up with 6 plus or minus root 76 over 10. And then what we want to do before we try to simplify these terms is see if we can simplify our entire radical and if it'll make any kind of a mixed radical, basically. So when I factored 76, I figured out that I could do 4 times by 19. 19 doesn't factor down anymore, but we know that 4 is 2 squared, and any squared values can move outside of the radical because we can root them. So 2 squared, if we square root it to move it outside, is just going to be 2. So we end up with 6 plus or minus 2 root 19 instead of 6 plus or minus root 76. And all of that over 10. So now that we have simplified it as much as we can see if there's any numbers that will go into all 3 of these values. And so, of course, that's going to be 2. So 6 divided by 2 is 3. 2 divided by 2 is 1. So we can just take out the coefficient for the radical. And then 10 divided by 2 is 5. So that's going to be our final answer here, is the 3 plus or minus root 19 divided by 5. Okay, so the next question you had was 4D, and so that's going to be the same kind of an idea. So down here you can see we had negative 2x squared plus 8x equals 3. So again, we want to set it equal to 0, so we can remove the 3, making that equal to 0 by subtracting it, and then we move it over to the other side. So we end up with negative 2x squared plus 8x minus 3, and then we just go through the exact same set of steps that we just did. So assign your a, b, and c values. A is negative 2, b is 8, and c is negative 3. And then fill it into your quadratic. So you should end up with negative 8 plus or minus the root of 8 squared minus 4 times by AC divided by 2a. That gives us negative 8 plus or minus root 40. So again, we want to see if we can factor down 40 to see if there's anything that we can move outside of the radical. And we get 2 squared times by 2 times by 5. So both of those are going to have to stay there to make root 10, but we can move the 2 outside, so we end up with negative 8 plus or minus 2 root 10 over negative 4. And then, again, just look for a value that you can divide into all of those. And so for 2, 4, and 8, that's going to be 2. And because we have 2 negative values here, it can be easier if you divide out negative 2, because if this becomes like 2 divided by negative 2 is negative 1, it doesn't really matter because you are doing plus and minus, so it's going to work out to be the same math anyways. So dividing out by negative 2 will get rid of these negatives, so we'll end up with negative 8 divided by negative 2 gives us 4. Negative 4 divided by 2 gives us, divided by negative 2 gives us 2. And then our 2 roots out here, and then because it's plus or minus, we don't actually have to keep the negative in there. So root 10 will be at the bottom there. Oops, sorry, that might have been covered up a little bit. Okay, so that was 4D. And then you had number 5. So number 5 was a word problem where you have a landscaper designing a garden, and she has enough crushed rock to cover an area of 10 meters squared and wants to make a uniform border around the garden. How wide should the border be if she wants to use all the crushed rock? So basically, you want to set up equations for the length and the width of this garden, but then because you're looking for only the area of the kind of like the frame or the border, you want to make sure that you subtract out the area, because you're looking for the total area around here, but you need to subtract out the area of the center part that won't have the crushed rock in it. So basically, I set up for this length of the garden. If you look at what we have here, I'll just move it down a little bit so it's easier to see. So basically you have the length of the garden is 7 meters, and we know that the width of the border, because it's going to be the same on all sides, right? Uniform border. So we can represent this width for all sides with x. And so if we think about the total length going from here over to here, it's going to be the 7 meters plus 1x on this side and 1x on that side. So basically we can represent this length as 2 x's plus the 7 meters of the middle part. And then the exact same thing goes for the width here, which would be, we have 4 meters plus an x plus an x. So we have 2x plus 4 is basically the statement that we can make for that. And then if we multiply those two together, we're going to get this total area, right, going all the way from one side to the other, and then, the width, basically, including the border. And so we want to multiply those two together to find the area, but remember we have to take out the middle part, so then we're going to subtract out the area of this middle section, which was 7 times by 4. Okay, so that's where this math is coming from. So 7 times by 4 is going to give us 28, and if we multiply out the length times by the width, we're going to get this value, right? So just make sure you do 2x times 2x, 2x times 4, 7 times 2x, and 7 times 4. So that gives us this value, minus 7 times 4, which is 28. And then we want this whole thing to be equal to 0. Oh, I don't think I described that before. So the other thing is that we wanted to say that this area that we're coming up with, minus the middle area, so just the area of this border, needs to equal the area of rock that she has to cover, which was 10 meters squared in the question. So we need to set this whole thing, like basically our equation for the area of the border, equal to the amount of rock that she has to cover that area, which was 10. So now in the next step here, because we always want our equation to be set equal to 0, we're going to move this positive 10 over onto this side by subtracting it. So that's where the minus 10 comes from. Okay, now what I did is simplified. So 4x squared stays the same, 8x plus 14x becomes 22x, and then we have, there's nothing out here being multiplied, so this is just plus 28 minus 28, which is 0, and then 0 minus 10 gives us negative 10. So now our overall statement is this, and our A value is 4, our B value is 22, and our C value is negative 10. So again, you can plug it into your quadratic formula. That's going to give you negative 22 plus or minus root 644 over 8. They wanted, how wide should the border be? Oh, actually, we didn't need to put this into exact values. I took it a step further and did the exact value, but you could have just solved using this. So if you don't want to, you don't need to do this. Basically, I just factored 644 for the value that I could move out front as a coefficient. So I have a 2 there, and then stays as root 161. And then because we have 3 numbers that can divide into 2, I divided those out. So I had negative 11 plus or minus root 161 over 4. But of course, like I said, you didn't have to do that because we want an actual number, like decimal value for the amount. So you could have just used this one and you would have gotten the same answer. You can try 2 different ones. Obviously, if you get a negative answer, that's not going to be acceptable. So you want to go with a positive answer, which was 0.4. And so that tells us that her border needed to be 0.4 meters wide. Okay. Let's see, the next question was number 7 number 6. So this is asking about basically on Mars, a ball thrown from the top of a spacecraft is modeled by this equation, and on Neptune the same thing would be modeled by this equation. So basically the y value is going to be your height of the ball at a given time, and your x value is going to be the amount of time that has elapsed. And so what they're asking for is how much earlier would a ball fall to the base of the spacecraft on Neptune than Mars. So essentially what you're looking for is, just kind of think about how that would be modeled, right? If we have something like this, so we're going to assume this is, here's our graph representing, right? So we have like our spacecraft, I don't know, that's not what real rockets look like, but let's just say so. And so it's going to kind of fall from the top of there, and when it hits the ground, then we're going to have a certain amount of time has gone by on the x-axis, and it'll be at 0 on the y-axis, which represents height. Okay, so it's always a good idea to kind of picture what the how the graph is representing the real life situation. Okay, so basically what we want to do is figure out what is our x-intercept here on Mars versus Neptune. So again, you're just going to look at the formulas. You're going to find your quadratic formula, fill it in, write your ABC values. And so for Mars, you should get 2 different roots. One of them is going to be negative. So with these types of questions, you always need to think about what would make sense here. So because there's no such thing as negative time, this is obviously not going to be correct. So the time that it will take for the ball to fall on Mars is going to be 3.713, some other decimal seconds. And on Neptune, it's going to be, there was a negative value, but we can eliminate that one. So it's going to be 1.45 something seconds. And then because they were looking for how much, let's see, it says how much earlier would the ball fall to the base of the spacecraft on Neptune than on Mars. You just need to compare these two amounts. So it's going to be the difference between them. So basically 3.713 minus 1.45 gives us a difference of 2.26 seconds. And so we can say that it's going to land 2.26 seconds earlier on Neptune. Okay. Okay, last question here is number 7. So let me just pull that one over. So suppose a pebble were to fall from a 200-meter cliff to the water below. The height of the stone can be represented by this formula. How long does it take for the stone to reach the water? So if you want, you can try and just pause the video and go ahead and try it, because this will be basically the same as the previous question. So maybe pause it, see if you can do it now that you've seen one question like that, and then you can come back and have a look at the solution. So basically with this solution, we were given our formula. We just find our A, B, and C values, which is pretty easy because they're right there. Plug it into our quadratic formula, and then again, of course, we need to find the positive value for time, which in this case is 6.7022 something seconds. And so your final answer, because they ask for it to the nearest tenth of a second, would be x equals 6.7 seconds. Should be your final answer for that one. Okay, so I hope that helped, and have a good weekend.